So I thought I'd set up a quick test using this air pump just to see what depression I can get out of it. It's a bit undersized for use in a flow bench, but it should hopefully do for testing. Essentially it's a 3-phase, half a kilowatt air pump and has both vacuum and pressure port. You just swap them over, 2 ports, one either side. It's driven by a 3-phase inverter and just connected up to a length of 90mm diameter tube. It's the same diameter as the MAF that I'm using, so I'll just cut this and put the MAF in the middle, do some testing. At the moment I've just got it hooked up to the manometer that I created when I first started doing tests, just to get some idea of what the depression is. It's woefully sort of underpowered really for use on a flow bench. I might get some comparative figures from the shop vac just to see what that draws. But I'm seeing about 6 inches on a 20mm orifice. So trusty saw blade orifice. See at this speed, we've got about 1, 2, 3, 4, 5, 6. There's about 3 inches depression. We can actually turn this up and overdrive it a little bit. 65 hertz. So overall differential there, it's about 6 inches. It should be fine for testing, but not really good enough for real world flow testing of cylinder heads and stuff. You can actually see that if I change this orifice to this pulley, it's about a 2-inch diameter hole. We're only really seeing about 1 inch of depression here, so it is massively underpowered. One thing I'm quite impressed with these pump motors is the noise. They're a lot quieter than vacuum motors, so even with a bigger one I think it would be a lot quieter to use this kind of pump than use a whole bank of vac motors. But we'll see how it does under testing anyway.